Hello, AP Physics 1, it's Mr. Ng with number 43 out of your homework set. Number 43 is a little bit weird in that it's asking you to actually measure the book, so you have to do some practical things in this. So it wants you to estimate the time between each photo flash. And if I have the distance, here, let's choose a brighter color. If I have the distance between each apple, and I'm going to use a stem because it's a nice dot. If I know that distance, I should be able to get the time with our trusty equation 1/2 AT squared. So the first thing I did was I found the change in displacement. Okay, and I did it 3 times over. So there's 0, and then there's for time 1, time 2, time 3, and I measured. Here's 1, here's 2, and then all the way down here, here's 3. And these are the measurements that I got. I got at 0, it's 0, of course, and then I got 1/2 centimeter, 0.5 centimeters, and then I got 1.1 centimeter, and this is me actually measuring it with a ruler from the book, and then I finally got 1.8 centimeters. But that's not a real distance, so the book then gives you another clue. It says that the width of this apple is 10 centimeters or 0.1 meters. So that means I just have to do a little bit of dimensional analysis. So that's what I did next, right? I did, where's my pen here? Oh, it's yellow. Okay, here we go. I did a little bit of dimensional analysis where I convert to, I don't know, let's call them real dimensions, right? Real meters. And the way you do that is you take this one, this is our fake one. I did 0.5 centimeters, right? And then the width of this apple is actually 0.1 meters. But when I measured the width of the apple is actually 0.6 centimeters. So for every 0.6 centimeters, it's actually 0.1 meter. Does that make sense? So I just did a little bit of dimensional analysis. The actual width of this apple, if I measure it, is equal to 0.6 centimeters. But that's supposed to equal actually 0.1 meters. So I set that up as my conversion factor. Okay, here you could see it again. That means that 0.6 centimeters is actually 0.1 meters, and I could set it up that way to get out of centimeters and into our meters, at least paper centimeters, like the centimeters in the photo to the real meters in real life. Okay, so I did that over and over again. So here, when I convert it, I turn these into 0.083 meters. This becomes oh wait, no, this is 0.0083 meters. There we go. I got this as 0.0183 meters, and I got this as 0.03 meters. Okay, the last little step. This step again is just dimensional analysis. Here, let's divide up our steps with this red line here. Okay, our last step is to find our t. And if you recall from d is equal to 1/2 AT squared, that means our t is equal to the square root of 2 times d divided by a. So I just plugged that in, meaning here for this one, my t for trial 1, my t is equal to the square root of 2 times 0.0083 meters divided by 9.8 meters per second squared, right? And the time that I got here was around 0.04 seconds. And then when I did the same thing here, when I found the t here, I found that the t here was 0.06 seconds. And then here, when I did it again, I got 0.08 seconds. That means if I just find the interval in between, the time in between each photo, the strobe, is around 0.02 seconds. Okay, so the trickiest part about this is not even the kinematics, it's just knowing the dimensional analysis, just measuring the actual apple am converting your little measurements into real meters, and I use the conversion factor right here, where 0.6 centimeters, which is the width of the apple, is equal to 10 centimeters, which I put in as 0.1 meters. Okay, I hope that clarifies things. Thank you very much for watching.